Hello everybody, my name is Ryan Nichols, and today I will be presenting my results for my case study from Agarwal Automobiles. So the data I'm about to present, it reflects the monthly fuel sales at Agarwal Automobiles, broken down by petrol, diesel, and HSP. The data set provides a clear view of the demand trends that occur over time, and it forms the foundation for building accurate forecasts by applying and comparing several forecasting models. And by doing this, we can identify which is the best fit for each fuel type and to predict future sales for both short-term operations and long-term planning. So let's talk about the best framework. So Kenneth Kahn's applied forecasting materials, what they do is organize forecasting techniques into categories such as judgmental / qualitative methods, time series / statistical techniques, lookalike and diffusion methods, causal / regression models, and then scenario / assumption models. And these, which that specifically is often used with new products. So for firms with good historical monthly data, like Agarwal Automobiles, and this data on their products, like fuel sales at a long-running retail station, Kahn's guidance points towards statistical time series methods as the primary approach. So this is typically augmented by judgmental adjustments and scenario analysis where there are important events or structural shifts. So for Agarwal, we use the time series statistical models, so the ETS, the Holt Winters, and the ARIMA as the core forecasting approach here. So plus we use regular judgmental review for promotions, policy changes, and then scenario planning for major structural changes. So this hybrid strategy is exactly why many forecasting practitioners recommend for existing product forecasts. So the types of companies that should use Kahn's approach, so that might include a startup company launching a new fuel type or a new fuel product or new retail format. They can use Kahn's lookalike, judgmental, and diffusion / assumption-based models because historical data is insufficient. Now, a commodity trading desk could also use this approach because it needs forecast volumes driven by macro prices, and there's more emphasis on causal / regression models. And then a fast-moving fashion brand such as Shein with short product lives could also use this because it combines judgmental and lookalike approaches and heavy scenario testing rather than relying only on historical time series. So the time series models tested and then the final choices. So here is what I did. So I parsed the two side-by-side monthly tables in the monthly sales data sheet and then created a time series for HSP, petrol, and diesel, looking at monthly data. So then we do the train / validation split over the last 12 months, and we use a holdout validation, and the models fitted on earlier history. So then the models tested were naive, and then we have 3-month moving average, SES, Holt's linear trend, the Holt Winters, additive seasonal, and then the ARIMA. All right, so here are the final chosen models and then the performance results from each. So again, like I said, the ones that I chose were diesel, petrol, and HSP. So you can see for diesel, the model chosen was the ARIMA. For petrol, it was the naive, and then HSP was a 3-month moving average. And then you can see the holdout MAE as well as the holdout RMSE and then the holdout MAPE. And those results are as seen. And then, let me see. So the mean for the HSP was around 8,447 for a sum of 101,368. The mean for the petrol was 104,723 with a sum of 1,256,676. And then diesel mean was around 155,420 with a sum of 1,865,046. So then that AR IMA produced a varying forecast reflecting the trend and structure for the diesel model. So why did I choose these? So for diesel, I chose diesel because it showed larger variability and persistent pattern that benefited from differentiating the ARMA terms. And then the ARIMA 212 minimized the AIC and produced the lowest RMSE on the 12-month holdout. So that suggests that the model, or that suggests that the series needed differencing to remove the trend and the low frequency movement, plus AR and MA components to capture autocorrelation pattern. For patrol, I chose this model because it was surprisingly stable in a level during the validation period. It was more sophisticated of the other models offered, and it performed worse on the holdout than the simple naive forecast. So when a series is stationary around a level, there is no consistent seasonal patterns, and the naive can be the best baseline. And then for HSP, it is a short-term, or it uses short-term level variations, and they were best captured by short rolling averages for about using like a 3-month MA, and the HSP had higher relative percentage error for the MAPE, but the MA3 minimized the RMSE validation. So other factors that Agarwal can consider would include fuel price changes, so retail taxation, and then any movement in subsidy. So immediate demand elasticity effects come into play here. So if a price shock occurs, then overall the model output will also. So we also need to look out for promotions and other marketing ploys like fleet contracts. So these planned promotions or a new corporate customer can create step changes in volumes, adjust forecasts upward and downward. Other factors Agarwal should look at also include supply disruptions, because it may force immediate operational decisions and it would alter the forecast numbers. We also need to look at weather, so seasonality that can occur that may not be fully captured by the model, especially if extraordinary, could definitely change the results. And then the last but not least is the inventory and the working capital constraints. So even if we have a good forecast, it's useless if the storage and the logistics cannot meet the demand. So those are the other factors, and then long-term factors would include structural shifts, regulatory policy changes, competitive changes, and then demographics and vehicle changes. And then recommendations and next steps. So I would recommend to use hybrid forecasting so we can keep the statistical models that I tested in production, but we could add a formal monthly review meeting where managers would incorporate judgmental adjustments and approve scenarios. So Kenneth Kahn recommends this for real world use. Next, we could add exogenous regressors. So we could build a regression /ARMAX Aramax models that include retail fuel price, local CPI, and temperature, and big local events. We could implement forecast combinations. So for mini-series, a simple combination of the top two models reduces the risk of overfitting. And then we could backtest and monitor that, so we can compute rolling handout errors monthly to detect model drift, and then we could refit these models on a regular cadence. And then the scenario stress test, we could run low, medium, and high scenarios. So we could do 10 to 35% price shock, or we could look at a sudden drop, whether that be anywhere from 10 to 30% as well in local traffic. And then we could keep the contingency inventory and the procurement plans. So that is my analysis of the Agarwal Automobiles case study, and thank you all for coming.